Hey guys, today I'm going to share with you tips that will supercharge your Surds foundation from dealing with the 4 operations of Surds, simplifying Surds, and solving equations involving Surds. We will also touch on the application questions involving Surds. So if you are ready, let's jump right in. In case you haven't already know, Surds are the square root values that cannot be written in the form of whole numbers or integer. So examples are square root 2, square root 3, or even square root 5. So let me share with you an analogy here. When we deal with Surds, it's great to remind ourselves one common saying: birds of the same feather, they fly together. So here are the 4 operations of Surds, starting with the addition operation. So the addition operation goes something like this. If you have 2 surds of the same kind, you can add the coefficients of them together. So for example, in part A, we have 2 root 3 plus 3 root 3, and this gives us 5 square root 3. Remember, birds of the same feather fly together. Alright, so for part B, we have 3 root 5 plus 12 root 5, and that will give us 15 root 5. So let's move on to the subtraction operation in 2a. We have 14 root 2 minus 4 root 2. Notice that the surds are of the same kind. We can actually minus the coefficients, which is 10 square root 2. For part B, it's slightly different here as it involves some fraction, but not to worry. Just need to take half square root 3 minus quarter square root 3, which gives us a quarter square root 3. Now from this point onwards, I'm going to publish the formula on the right side of the screen for your convenience, so make sure you memorize and remember them. So let's take a look at questions involving the multiplication operation. In part A, we have square root 3 multiplied by square root 2. Now the very first thing that you must ensure is that they have the same square root, such as this. Alright, so if we have ensured that this is as such, we can actually house them under the same square root, and to combine the 2 terms together, 3 times 2, which gives us square root 6. Let's try another example. We have square root 5 times square root 3 times square root 2. Alright, we have noticed that the surds, which is the square root over here, is actually the same. So what we can do is to house them under the same square root again. 5 times 3 times 2, which gives us a value of 30. Now part C is slightly different. There's a coefficient in front of the square root. But not to worry, what we can do, remember the saying birds of the same feather, they fly together. You're going to take the coefficient of 3, multiply by 5, and with that square roots over here, we're going to take 2 multiplied by 3, and this will give us 15 square root 6. Now the 4th operation is the division operation. Usually for surds, this operation is written in the form of a fraction, such as this. We have a square root 50 divided by square root 2. All we need to do is to ensure, first thing, that the roots are the same. This is a square root divided by a square root, and we can house them under the same square root, which is 50 divided by 2. This gives us a value of square root 25, which gives us 5. Now this principle doesn't work if we have, say for example, square root 50 divided by cube root 2. You realize that the roots are different. This is a square root, this is a cubic root. So it is not possible to apply this principle. Now let's move on to the next example. We have square root 64 divided by square root 16. Very first thing is to ensure that they have the same root. And what we can do is to combine them together under the same square root. 64 divided by 16 equals to square root 4. Now some students leave this answer like that, but it is not correct because we want to simplify this as much as possible. So this gives us a value of 2. I have another bonus tip to simplify surds. Now if we have the root of 3, for example in part A, multiplied by another root of 3, we will have 3. Alright, So for part B, if we have a root of 12 and we multiply by the root of 12, and this will give us 12. Alright, but this part C is slightly different. If we have the root of 5 multiplied by the root of 5 and multiplied by another root of 5, it will not give us 5, but rather it will give us 5 square root 5. So it is really important to know this concept before we move on to the next stage. So we'll now deal with more advanced questions to simplify these Surds expressions. Now I have one tip for you. For example, if we see something like this, square root 8, all we need to do in the very first step is to think about the factors of 8 that can be square rooted. Now the factors of 8 are 1, 2, it could be 4, it could be 8 itself. Identify that factor that can be square rooted. In this case, it is 4. So square root 8 has factors 4 multiplied by 2. All we need to do is to split 4 and 2, and this will give us 2 square root 2. Let's try another example. So for part B, square root 20, so think about the factors of 20 that can be square rooted. 2, it could be 5, it could be 10, alright, it could be 4 even. Right, so one of the factors that can be square rooted is actually 4. So we are going to take 4 multiplied by 5. Split them up just like the above question, and we will have 2 square root 5. Now let's try another example. We have square root 18. So one of the factors would be 9 and multiplied by 2, which gives us 18. And we're going to have square root 9 times square root 2, which is equals to 3 square root 2. Let's move on to part D. So we have square root 12 plus square root 27. I'm going to select 4 because it can be square rooted easily. And I'm going to select 9. So what we have over here will be 2 square root 3 plus 3 square root 3. Remember, birds of the same feather, they fly together. We have the same surds over here, so we can add the coefficients together. For part E, not to worry, we have 2, 4, 3 minus 3 square root 48. Seems like a huge number, but we can think of 2, 4, 3 and break them down into 81 multiplied by 3 minus 3 and 16 multiplied by 3. To be very fast at this, think of the factors of the numbers that can be square rooted. So we have 9 square root 3 minus 3 square root 3, and this will give us 6 root 3. For part F, 1 plus root 8 and 2 plus 3 root 2. We're going to multiply the terms one by one, not to worry. So 1 multiplied by 2 and 1 multiplied by 3 root 2. Alright, so the next term will be square root 8 multiplied by 2 and square root 8 multiplied by 3 root 2. We can write the term something as such. Alright, so you realize that these terms don't really have the same surds, but not to worry, we can actually simplify them down further, such as this. The constant terms can be added together, and the two surds over here, which are the same, we can add the coefficients together. Now we are going on to part G right now. It is a very important question. This is 3 minus 2 square root 3 square. Alright, if you haven't already know the formula, it appears on the screen right now on the right hand side. It is a square minus 2ab plus b square. It's a very important formula to apply to this question. All we need to do is to put 3 square minus 2a and b plus b square. Now to simplify this further, all we need to do is to combine the like terms, meaning 2, 3 and 2. without any surds, we can combine them to give us 12. And to simplify this expression here, what we need to do is to take 2 square and square root 3 square, which gives us 4 multiplied by 3. To simplify this further, we will have 21 minus 12 square root 3. Now if you want to go one step further, we can factorize by taking out 3, and we'll be left with 7 minus 4 square root 3. Now part H is one of the most important questions that you will need to know. Let me give you a quick tip to increase your speed for such questions. The very first thing that you must recognize is that this takes the format of A minus B, A plus B. If you see the formula on the right, it gives us A square minus B square. So all we need to do is to take 2 square minus square root 7 square. That will give us 4 minus 7. And very simply, the answer is minus 3. Well done in completing these sections of surds. In the next part of the video, we are going to cover simplifying surds by rationalizing a denominator and solving equations involving surds. If you need further practice, do check out the free downloadable practice questions linked in the description box below. I've prepared some work answers for your reference too, which will hopefully help to solidify your foundation. Do leave any questions or comments if any, and thank you for watching.